chlorine to you guys? Okay, cool. I'm going to keep writing them that way because that would be very difficult for me to stop. But okay, so first, this guy goes, hey, I see an acid. And you know what I can do with an acid? I can protonate myself. You know what? So, here's the deal with these. This is how lazy people write benzene. You are only allowed to do this if benzene is definitely not participating in the reaction, like at all, okay? Deal? If benzene does anything useful, you have to write it like this. Honestly, it's not a bad idea to probably write it like this all the time for now. But also, we're not actually gonna do things with benzene until we get to the benzene chapters. So if you want, you can write it like this until we get to the benzene chapters. But then you have to start writing it like this. Deal? Everything. This is that. H. Okay. Now we have that, and we have. Wait. Yeah. Are those too close together? Is that very clearly not connected? I'm going to draw a little lower, and then it doesn't matter. There. Now we've got these things. So we are going to I'm going to redraw it because I don't want to sneak back and forth. It's going to turn into a mess. Okay, so when we protonated this, we made this carbon into a better. What?
Electrophile.
Yeah! That carbon became a better electrophile, right? Or I guess if we're getting rid of, because honestly, I don't care if you know the words for those things, right? Like I haven't yet done any questions where I just have you identify a nucleophile or electrophile. If I did, okay, so it's probably a good idea to know those, but like, I don't know, whatever. If you don't know them,
I think yesterday our TA had them backwards.
see, it's super easy to get them backwards. That's why I make you guys promise me that you will interrupt me during lecture if you have problems, because there's just no way I'm gonna not at some point mix up things like that. And it's very confusing to hear something explained incorrectly or correct backwards, with words that are backwards, but it's gonna happen almost no matter who does it because it's just it. All right, let me draw out that carbon because we like to do that. H, O, H plus. Just thoroughly dyeing my hands. Okay, so I'm gonna draw nucleophile, electrophile kind of things because we sort of technically are, that's sort of technically what's going on here. Because this guy, this has a whole lot of electron density on it, doesn't it? So it kind of looks like it could act like a nucleophile. See, now I've got to check before I say. Okay. So we have a nucleophile and an electrophile, and we can do that. Standing in front of things is not overly useful, but. now we got this thing. This is our tetrahedral intermediate. Does it need to be named that? No, but I mean, we went from a nice little planar, trigonal planar boy to the tetrahedral shape, so. Okay, we're gonna, no, there's room to switch over there. We're gonna do that, because otherwise I'm gonna be sitting on the floor during the next couple things. Okay. So now we have this. Then I redraw with all the colors. Okay, now we've got this guy, and we're gonna do a rearrangement. So, and what's the reason we're gonna do a rearrangement? What do we have here that is just not as energetically stable as it could be? Or what do we have here that, like, oh yeah, when we're talking about favored, or making things more stable, lower energy,
Carbon to oxygen double bond.
yeah, we've got carbon-oxygen single bonds, and when we talk about bond dissociation energies, two carbon-oxygen single bonds, it takes less energy to break both of these than it would take to break one carbon-oxygen double bond, which means that the compound must be more stable, right? If it's a carbon-oxygen double bond, like, the compound is lower energy in itself because it would take more energy to break that double bond and get it to, I guess, just, what would that be, a hypothetical carbene, sort of? Yeah, just break that and make a hypothetical carbene or whatever, than to break both of these and get to the same energy level, right? So, rearrangements driven by the desire to make double bonds. We are gonna do, shit, do I need to write that? No, that's not what it is. Yeah. Okay, we're good. Okay, so, let me just angle this a little bit. That's sort of, okay. What kind of rings does nature really like? 5 and 6, right? And we've got 5 components here, and that could, no wait, never mind, JK, that can't be, that's not a special hydrogen. We're not getting hydrogen bonding, but this can easily arrange itself such that this is close to this, yes? Because of that, that kind of does happen, and this oxygen is like, hey, you know what? I've got all sorts of these lone pairs. What if I just steal you? And so it does. It's like, I would rather be protonated, bye. And when it does that, sorry, it's cyclic, so it's not that I have to see which arrows happen. I have to see all the arrows and figure out what order to write them in, so I'm explaining it in a way that makes sense. So we're gonna do that. These are gonna go where I think they are.
Oh, they go to the red oxygen.
Yeah, they're gonna go here, and then these are gonna go here. Yeah. And then, oh, okay, I mean, I guess, sure, this can go up there too. They also have that stuff in there. I don't know, I mean, I feel like you could just, like that stuff isn't entirely necessary, but whatever, it doesn't have a double bond there. this also reversible? Yeah, everything's reversible because it's ketones. Okay, so now we've got that carbon has a double bond. Can I switch? Yeah, they're color coded, so I'm gonna switch it so that it looks nice and like a carbonyl. Has that guy, and then, yeah. And then we've got that left over, because it was already there. And we get that, and this is and we get hypochlorous acid at the end. So, I think the color coding is pretty useful, partly because, well, I mean, it's nice to see where everything goes. But also, there's a question, one of the questions I picked out in your homework talks about labeling, radioactive labeling. So, is it carbon 18? I want to say carbon 18 is a common radioactive isotope. Right? Or, did I say carbon? I meant oxygen. I think I said carbon, didn't I? Okay, sorry. Oxygen. Oxygen 18, I think, I could be wrong, is a common radioactive isotope. Usually when we mark something as a radioactive isotope, we really just like give it an asterisk, either like there or like right in the middle of the oxygen. But like color coding is better. But there's a question that involves that, and what if you did this, then what would happen? Or something. Let's see. I'm trying to figure out what this like last step is or where it came from. Is this a problem from later? Oh, okay. They have a name for it. All right, fine. I guess that is part of. It just seemed to me like. It seems to me like a step that doesn't involve anything, so I don't care about it. But it's labeled scavenge the hypochlorous acid. All right, fine. So apparently it's important that we scavenge the hypochlorous acid, because. I'm sure there's a reason. It's probably just like hella reactive or something. So we're gonna take that guy and we're gonna add this 2-methyl-2-butene, and since I wrote that civic there, we're gonna do this. This is also reversible, and that is going to give us, wait. Okay, there's, no. Gonna do it this way. Okay, so we're going to break that double bond and do an addition reaction where we get that. Yeah. Scavenge the hypochlorous acid. So, that's the final step. If I were to have you guys draw me this mechanism, interested in the mechanism until we get to the thing we want. And if there's other, I mean, granted, this isn't, it's not, we're not drawing the mechanism, so it's just like an extra step. I don't know. This step doesn't matter, like, to me, if I'm testing you on something, because once we get to the final product, I don't care what's left over. Okay, will not oxidize alcohols. Four. I think my alarm's about to go off, like right now. So, yeah, 45 is when we usually do the break. So, go ahead and take a break. I'll move these away from actively locking the door. And, there it is. And we'll come back and talk about updating.